Okay, today we're going to do a full 3D optimization of this same thing that we've been working on here in a couple tutorials, which is this big block here. If I go ahead and show you again what we're essentially doing, I'll turn off some of these components, turn on baseline and shade it. Here's our familiar frame, but now instead of optimizing tube wall thickness, etc., we're going to do a full 3D optimization. So what we've got here is the model is already set up, and of course you can download it from below. There's a zip file that has all the files that we're going to be using today. So this is a big massive block of 3D elements. Now 3D is much more involved than 2D, so this is going to take forever to run. So we're going to do some shortcuts as well today. Let's take a look at this. Go down to Tool, do a mass calculation, show you how big this thing is. If we just click on this and go calculate, it comes up to 4.7 tons. So this thing is huge. Okay, let's go ahead and optimize this thing and set it up and run it. Go down to Analysis, Optimization. This is a topology optimization. So you got a variable in here, and we'll call it whatever you want. Topology. It's not a P shell. This one is a P solid, and the properties we're going to optimize are the solid one here. So we're going to select that and hit create, and a design variable has been created. We're going to do one more thing on parameters here. We're going to set a minimum. Let's turn off maximum member size. Minimum member size, let's turn to 60 millimeters. That'll essentially make tubes on here in the final structure that have a minimum size of 60 millimeters. So we're going to update. Oops, we're going to turn off that. Now update, and we have updated this design variable called top. Let's hit return on that. Let's go create our responses. We have we can select down here. We selected mass, and we're going to call it mass. Oops. Right, mass. All right, and it is we can do it as a sum here, and I can take these properties. Again, the property I want is the solid property. That's the mass I'm going to optimize. So we're going to select that and create this response. Okay, let's create another response. We'll call it the displacement, and it is a static displacement, just like we've done before in all the other videos. And let's go in here and select for the node, that one right there, and it's a total displacement, and create. All right, so now we have our responses. Let's go ahead and constrain one of them, the design constraints. Okay, the constraint name is, we'll just call it CS1, and we're going to put an upper bound on that of 5, and the response we're constraining is the displacement, and that's for load step, the first one. And now we're going to do the same thing, CS2, and it's going to be 7, same response, load step 2. Alright, and then we're going to do CS3, and it's the same 7, and everything different is that's load step 3. Okay, so now we have our design constraints. We just need our objective here. And our objective is to minimize our mass response and hit create. Okay, we're now ready to run this thing. If we go down here to set this up to optimization, and you can run it. The only thing is, on a server, well, this thing takes a long time. So what we're going to do instead is save you that time. I don't have a week to run this. Is we're going to go over to HyperView, and we're going to just load the results files, which are available in that zip file, which you can download from below. So let's go over, pretend we ran this, and let's go over to HyperView and look at our results. Okay, here we are in HyperView, but before we do that, let's go and open up this folder. This is, if you download the zip file down below, it'll have these files in here. The HM is the file that we just worked on in HyperMesh. Now let's go look at this out file. You don't need to, but let's go ahead and let's edit that and have a look at it. Okay, here's the file. Let's zoom up to the top. Okay, and it's just setting up the file and all the optimization, the parameters. And if we scroll down to the bottom here, you can see it's going through all the iterations. Iteration 8, it finally goes through 52 iterations. So here's the last iteration, and we see that our mass is now 72 kilograms. So that's down from what, 4,700. All right. And the other thing to look at is this file. The execution started, see down here, it started on, it's an old file. Again, we're loading up some results. Started on July 5th and ended on July 7th. This ran for 49 hours on a system with 8 memory cards in it, I believe it is. So there's, on your laptop, if you're running this at home or whatever, it'll run for weeks on end. Okay, so that's the file. It's kind of interesting to look at, the optimization as it goes. Back over to here to HyperView, we're going to load a file. If we click on here, we can go over to that same directory and let's pull in this h3d file, this des.h3d. All right, and we'll hit apply. And here's our file. And as before, we can go over here and let's go down to the last iteration. And we hit contours over here, pick our components and apply. And we can see there's some kind of structure in here. Let's go over to ISO like we've done in the past. Pick our component and apply, and now we can look at the structure. So here's as it's forming. As we change the densities, we can come up to this somewhere in here, this very cool 3D structure that's been optimized. Now that's pretty cool, and that satisfies all the constraints that we had on the system. And I think that's a really neat output example. Okay, we're going to do some other optimizations as well, but we'll probably keep them a lot simpler so that we can actually run them. I hope you enjoyed this, and take a look at this result and let me know if there's any other optimizations you want us to play with. Thanks for watching.